You bring your ammonia machine. That's fantastic. Of course. Why not? No. I just did it from Madam Akira. So I get an anti-rider intention. Why is there so much? I feel like that's honestly not that exciting. Okay, but like it's not exciting though. Like no one. The lead as a hospital. Oh, she's gonna pay us as well. I think it's because Sudoku is gonna leave. Sudoku is gonna leave. That's not the answer. But the default language of he comes from 1 to 10 in Chinese. What's 1 to 10 in Chinese? Okay, come to 10. Yeah, so you can't you can go from 1 to 8. You can come from 1 to 5. You can come from 1 to 8. Okay, 3 is 10 or 2 is 10. Okay, last point.
Huh? Sorry?
Are you calculating it from the start instead of 10 p.m.?
No.
Oh, perpendicular distance only 35, right?
Okay, let's look at the six steps. Step 1, pivot. Where's the pivot? Here, right. Step 1, Step 2, how many forces are there? 20 Newton, 2.5 Newton, and W. So 3 forces. So for each force, there must be one perpendicular distance to the pivot. And number 3 is the one that we always make mistake. I may even make mistake. So what is the perpendicular distance of each 20 Newton to the pivot? 10 to 45. What's the perpendicular distance? 45. Right put here. How about this? This thing is having CG in the center. So the perpendicular distance is 5. Because the pivot is at 45. So 50 minus 45 we get 5. Okay? Why not? Huh? Sorry? Repeat the last lecture. Pivot here at a 45 cm mark. Pivot at a 45 cm mark. Where is the center of gravity of this rod? At 50 cm mark. Why? Where does it tell you that it's at the center of the uniform? What is the weight of it? 2.5 Newton. So from here to here, what's the perpendicular distance? 5. And how about the last one? My W, what is the perpendicular distance? It's at 100. To the pivot it is 45 cm. So 100 minus 45 we get 55. Okay? Step 4, multiply them together to get the moment. 35 times 20, 700. 5 times 2.5, 12.5. 55 times W, 55 W. Step 5, direction. Okay? Pivot here. So this will be anti-clockwise. This will be clockwise. This will be clockwise. Is it in equilibrium? Apply step 6 principle of moment. Total clockwise must be equal to total anti-clockwise. So why is it that I got it wrong? Where did you get it wrong? So please be careful. Okay, please do it systematically. When I say 6 steps, it will guarantee your marks if you do it systematically. Okay? Step 2 tells you how many forces there are. So each force, there must be a perpendicular distance. Okay, let's do question 2 now. Okay, question 2, I think I went through this in the notes, right? What's the answer? You all need me to go through this again? Need or do 6 steps can? Okay, then Keith, do it with me. 6 steps. What's the first step? Pivot. Where's the pivot? You want it at X, right? Okay. Although there are 2 supports, by right got 2 pivots. Got 2 support, by right got 2 pivots. But choose only one as a pivot. And Keith chose the pivot at X. So this is our step 1. Are we okay? Step 2, how many forces are there? 2. What are they? 0.24 and 0.26. Is that all? The reading shows 0.24. That means something is pressing down on the weighing scale with a force of 2.4 Newton. That means something is pressing down on the scale with 2.6 Newton. Correct? So what do you think is the weight of the rod? What is the total downward force? So what should be the total outward force? 5. Because this thing weighs 5 Newton, but the weight is distributed among 2 points, right? So you are now the rod. Your weight is 5 Newton, pressing down, right? That is a force weighing down on you. How come you never drop down? Because your head is supported by an upward force of 2.4. Correct? Over here, your legs are being supported by a upward force of 2.6. You get this? This is the rod. You are the rod. What is your weight? 5 Newton. Why doesn't you fall? Because you are being supported at 2 points, right? And in order to support you, the supporting force must be up or down? Up. How much? 2.4 Newton. Here will be 2.6 Newton. This is the force that is exerted on the rod. What is the force exerted on the weighing scale at X? What is the force exerted on the weighing scale at X? 2.4, up or down? That is a action-reaction force. Rod pressed down on the weighing scale with 2.4. The weighing scale exerts a equal and opposite upward 2.4 Newton on the rod. Understand? But now we are interested in the forces acting on the rod. Acting on the rod. Not acting on the weighing scale. So, if I were to draw it like that, does it show all the forces acting on the rod? Yes or no? Yes, it's all acting on the rod. Yesterday I said don't need to listen, but you need to copy down. Don't copy it on the back of this. Hey, these I'm going to feedback about you. So does it show the forces acting on the rod? Yes or no? Yes, So now we proceed. So Keith, where do you choose your pivot? At X, So this is X. So this is the pivot. How many forces are there? 3. 2.4 upwards, 2.6 upwards, and 5 Newton downwards. So 3 forces. So for each force, we need to identify their perpendicular distance to the pivot, which is the difficult part. Okay? So what is the perpendicular distance of this 2.4 to the pivot? 0. So later on, will there have a moment? No moment, because moment equals to force times perpendicular distance. How about for the 5 Newton? Is there a perpendicular distance? Where is it? Here, right? So shall we call it D? And we call it D. How about this 2.6 Newton? What's the perpendicular distance? It's 1.8. 1.8. So that is step 1, 2, 3 done. Pivot, number of forces, and perpendicular distance of each force to the pivot. Now, step 4, calculate moment. We already say that this one, because the perpendicular distance is 0, therefore there will be no moment. So we just do this 5D. Okay? Simple. How about the other one? 2.6 times 1.8. Do we have a calculator? 4.68. Thank you. Is this thing in step 5, direction. Is this 5D, this moment, is it going to be clockwise or anti-clockwise? Clockwise, do you all need me to show you the pen trick? No need, or no, How about this 4.68 Newton meter? Anti-clockwise. Okay, so is this thing in equilibrium? Yes, not moving up or down. So step 6, apply principle of moment. So 5D equals to 4.68. So Davis, don't mind what's the answer? 0.93. That means my 936. Okay, that means my D that I label here is going to be 0.936. All okay? So what is the center of gravity of what is the distance of center of gravity of the steel rod from NX? So answer will be D. Try question 7. I think it's in the notes. But I want to highlight the part about line of action of the force. Line of action of the force, which so far we have not done. Okay, so although we have done this in the notes, but I want to highlight the idea about line of action of the force. So I put down the dimensions first. Okay, so for 10 Newton and X being the pivot, so what's the perpendicular distance of 10 Newton? Anyone? 4. So how do you get 4? Basically, you need to extend line of action of the force. But there will be some students at the start, they will choose 2 meters. Okay? You actually need to extend the line of action of the force, and then from the pivot, that will be the perpendicular distance. Okay, hope you all didn't forget about this. So if you know about this, then for 5 Newton, it will be 1 meter. For F, it will be 1 meter. And anyone confused about the direction of the moments? Need me to go through or don't need? Okay, so for this kind of rectangle, you can actually use your calculator. You hold your, in this case, it's pivot. If it's a thin rod, you can use your pencil. For this, the pivot is in the center. Yes, you hold it like it is. Now, for the 10 Newton, it is found on the right hand side. And it's going down, so you press down. Clockwise or anti-clockwise? Clockwise. And this one, X, you push it here, clockwise or anti-clockwise? You can do a simulation. Right? So, can be done. How about L shape? How about L shape? If let's say the pivot is here, L shape, how do we know whether clockwise or anti-clockwise? So again, you can take out a pen. Question 9. Question 7, answer is B. Question 9. Made of 3 different materials, increasing order of density. Equal mass distribution, that means it's a uniform cuboids. Okay, so do we have an answer? What do you think? Answer is D. Okay, they require the same angle of tilt because they are CG, they are all right smack in the middle. Okay, so they require the same angle of tilt. Once the line of action please copy this down. Once the line of action of weight, once the line of action of their weight falls outside of base area, this is one of the key terms that you will have read in my set of notes. Okay, if it falls outside of the base area, it will topple. If it stays within the base area, it will go back to its original position. Okay, so these are terms that you need to use in your explanation questions. Okay, so it's not just calculation, yeah. Then they have the same vertical distance from the ground level to their center of gravity, which is to say that they have the same position of their CG. Alright. Then lastly, the iron block requires more force to topple. What do you think? Because iron block is the denser, so it has the greatest mass, so it therefore has the greatest weight. They they don't have equal mass, they have equal mass distribution. That means it's uniform. Okay, so this part is important. They do not have equal mass. They have equal volume, different density, therefore different mass. Okay, so if it has the greatest mass, then it has the greatest weight. So a larger moment will be required to topple it over. So if you look at this, the perpendicular distance is the same. Okay, the perpendicular distance is the same, but W1 is greater than W2. Right, so the moment created by W1, the moment created by W1 will be greater than the moment created by W2. But they all have the same shape. They all have the same shape. Which one? So these two forces, if they are equal, the pushing force are equal, which one will, or let's say if they are not equal, I push them from this position, same position, right? Which one will require a larger force to make it topple? Weight 1, right? Because the moment by weight 1 and the same perpendicular distance is larger than the moment of weight 2 and same. Of weight. Yeah, just now I forget to say. Once the line of action of weight, that is regardless of the pushing force. Once the line of action of weight falls outside base area, it will topple. But what causes the line of action of weight to fall outside? It is the pushing force. Right? This is the object. If nothing pushes it, will it topple by itself? It wouldn't. Then now comes a pushing force. So now it becomes like this. Okay? If the line of action of weight still falls within the base area, it will generate a returning moment. But if it falls outside, like that, right? This was the original base area. So then you will topple lah. On the pivot, like that. That's what you all always do, right? You all do on chair, right? You all like try to balance, right? But is it easy? Because either way, if it shift to the left or to the right a little bit, it will either go back or you'll fall. So that's why you cannot put your phone this way. You can't. This this is stable. This is unstable. Actually, it will go back to its original. The stable equilibrium and unstable equilibrium and neutral equilibrium, is it still in our syllabus? No. Okay, since we have time, a little bit, in case O level they pull a fast one on us. This is stable. If I put a cone like that, it will be stable equilibrium. This is unstable. That means any slight movement, it will topple. And this is neutral. I roll it around, the CG will remain at the same place. Okay? Although they say that this equilibrium thing is no longer in our syllabus. Okay? Okay? So besides the calculation, you also need to know the explanation. Right? Next lesson, I'll still see you all one more time, then we do pressure and energy. Okay?